So yes, welcome everyone to the very first workshop, the Erasure CoinList hackathon. I'd like to welcome Stefan, James, and Peter from the Numerai team, who will be your facilitators for this workshop. So yeah, over to you guys.
Thank you. Yeah, welcome everyone. This is super exciting to be launching this hackathon. We have a lot of anticipation to see what kind of response there will be from people building on top of Erasure and the kinds of toolings that people are going to come up with. I have put together a bit of a structure for the workshop, so I'm going to share my screen, and then we'll be able to take it from there. Okay. All right, I suppose everyone sees this correctly. So pretty simple agenda. Start by talking a bit about Erasure, where it fits into the story of Numerai, why we built it, why we think it's so great, the kinds of applications that we've built on top of it, and why it's so important to be hosting a hackathon like this to encourage people to build the right tooling for the protocol. Then we'll go a bit more into the depth of what the Erasure protocol is all about, what are the core primitives that go into it, and also talk about project ideas. So the kinds of toolings that we think would be really exciting to see, and we'd encourage people to tackle during this hackathon. I've put in Q&A at the end here, but if at any time during the workshop you have a question, I invite you to use the chat on the web call and ask the question there. I think there's a little button that you can raise your hand, that kind of stuff. I will try to get to it right away so that we keep it current. So without further ado, let's talk a bit about Numerai and Erasure. So for those who don't know, Numerai is a data science platform that has really just a small component of it that's built on top of Ethereum. The reason why we use Ethereum and the reason why we have a token attached to it is because of a quite simple concept, which is the idea of having skin in the game when you're making predictions. And so all the data scientists on our platform come every week and they make predictions on what essentially the stock market is going to look like. They stake their predictions with the token. If they're correct, we reward them, and if they're incorrect, then we punish them. So essentially, there's this whole new, application that's possible, which is a Numerai tournament that was never before possible without using a platform like Ethereum. And it's enabled by this very simple concept of skin in the game. What we've realized, though, is that there's very few other platforms that have integrated such a simple primitive into their applications, if you think of just traditional Web 2 applications. So what we set out to do with Erasure is to bring those primitives, simplify them to the point where it becomes quite easy to integrate into any website. So that's the core of what Erasure is trying to achieve. And we really think it can solve some quite fundamental problems with the web that have sort of solutions these days, but aren't quite there, quite the last solution for it. One of them is bot defense. So one of the things that you get by default when you put skin in the game for all your users is it becomes infeasible to create bots that exploit your systems. It's sort of an implicit Sybil resistance by making sure everyone has something at stake. The other thing is that the past is easily forgotten. And the example that I like to give here is, on Twitter, you can make a lot of predictions. For example, on the results of the 2020 elections, you're going to say, hey, Warren's going to win the Democratic nomination. But then what happens is that you actually make tweets that say that every other candidate is going to win. And then in 2021, when you already know what the result is, then you delete all the ones that are wrong and you seem like a genius for having predicted the outcome. So with tooling like Erasure, you can prevent people from easily deleting data and forging essentially a positive track record. Another one is that local knowledge is undervalued. So this is sort of the idea that with systems like Pirate Bay, it became very easy to share files that were useful to a wide variety of people. So for example, movies that have broad market appeal, that is, sort of has a small value to a lot of different people, it became easy to share because everyone sort of had an incentive to host it because they knew there was a lot of demand for it. But in a system or a marketplace where you're trying to share information, share data that's highly valuable to very few people, then it becomes quite difficult to do in a peer-to-peer manner. And so you're stuck having to deal with these intermediaries that are able to censor and all that good stuff. So Erasure is also an attempt at solving that issue of making a marketplace for data that is very valuable to very few people. All right, so we've built a couple applications that essentially take all of these components and combine them into something that's usable today. And that's something that I want James to talk a little bit about. The first one is called Erasure Quant.
Cool. Thanks, Stefan. Sorry about that. Yeah, so I'll take you through first Erasure Quant, which is live today. You can go to erasurequant.com. This is a kind of, it's the first application that we built on Erasure, and it actually sort of helped us figure out the direction of the protocols we were developing both in tandem in the beginning. So you can check it out. Basically, Erasure Quant is our first kind of traditional data science competition built on Erasure. So like Stefan mentioned, Numerai also is one of these data science competitions, but and it is using Ethereum, but it also has custody over users who don't want to have to use Ethereum. And one of the main components of the Numerai data science tournament is that the data is encrypted. So we're giving out homomorphically encrypted data to users, and they can run a model with it, but they can't necessarily understand what the data is or what it's telling you. And we wanted to experiment with what does it look like if, because we do hear this feedback that some data scientists would like to play some sort of a stock picking game, but they want to actually be able to choose their data sources and understand what it is they're analyzing. So we decided to run with that, and basically the way Erasure Quant works is users every day or however often they want, they upload a prediction, and what happens when they upload it is we calculate what is the IPFS hash going to be for this file, and then we can put that on chain without uploading it yet. And that's sort of the basic proof of existence. Later, the user can come back to reveal it and prove that that is the file that they had committed to earlier on. And so we're giving users their own public track record of their predictions. And what's nice about this is that this is actually portable. It's not something that we own. It's something for everyone to see. And so that's one of the benefits here is we think that when a data scientist is doing work, whether they're participating in some sort of a competition or they're doing something for someone else, it'd be really nice if that person could build up their own track record that they could use in other platforms later on. But yeah, so that's the basic flow. I can talk a bit more about the architecture or the usage, but basically the basic flow is, user commits, later reveals, and they have to stake on their predictions. And once they've revealed their predictions, we're able to score them against market data and make payouts according to their performance. And I'm happy to go into more about the technical side of how we built this, but I think for now I can move on to talk about Erasure Bay.
Let's move on to Erasure Bay. I think one of the interesting things about these applications is sort of highlighting the different components that are quite specific to working on top of blockchain. And these are the components that we've had to implement on our own, but is something that is a huge opportunity to standardize and provide tooling for, such that other people building these applications don't have to implement themselves. So these are all things that sit external to the smart contracts, but are necessary. So I mean, with that, let's move over to talking a bit about Erasure Bay. Peter, do you want to talk about it a little bit?
Sure. Whose mic is on?
My mic.
Okay. Do you guys want to mic off and I'll mic on?
Sure.
I guess I should probably keep that off. How do I mute myself? Unmute. Sure. Okay. So I can talk a little bit about the idea of Erasure Bay. So everything we've talked about so far and sort of Numerai's origin story is very much around predictions marketplace. But predictions are only a subset of information, a very small subset of information. And so Erasure Bay wants to be the general use case of a decentralized information marketplace where any type of information could be bought or sold. And the key primitive here is that if you want to sell something on this marketplace, let's say it's maybe a 0-day exploit of software or some proprietary knowledge that you have about the way, I don't know, some election is going to come out or some scandal is going to break. In order to be credible, you need to stake. So the idea is you set a price, you set the amount that you are willing to stake on that, you set the ratio at which you're willing to be griefed, and the period of time during which the buyer of your information would have the ability to grief you. And so this is just, Erasure Bay is effectively the general use case of the Erasure protocol.
Perfect. Thanks, Peter. All right, I'll get back on the mic. I think I did it.
Yeah, you're good.
Okay, sweet. So let's get a little bit more into what the architecture of the protocol is like today, and where we see it going in the future. How do we bridge that gap? So at its core, there's 3 primitives for Erasure, and those are quite simple. They're recourse, track record, and payments. So recourse is all about this skin in the game that I was talking about earlier, which is enabled on the Numerai tournament platform. It's about putting some tokens in a stake and allowing someone else to destroy those tokens based on a certain set of rules. So for example, if we're exchanging data, then I could put some money at stake, claiming the accuracy of the data. If the data doesn't meet this accuracy benchmark, then my counterparty that's buying this data would be allowed to destroy my stake. The other component is track record. And James talked a little bit about this with Erasure Quant, where the users are building this history of predictions on the stock markets that is timestamped on the blockchain, such that even if we, for some reason, stop rewarding them for making those predictions, it's immutable that they can take that reputation, they can take that track record and bring it over to another application and essentially use it there to bootstrap their credibility. And that can be seen a little bit like a credit score. So it's a history of actions that have been taken that can be ported from one use case to another. And then the final one is payments. So this is about being able to do programmatic value exchange. And that's really big in the use case of Erasure Bay, where I'm essentially putting up a bid for a certain type of information, but it's a request. I'm not sure if there's anyone out there that has it. So I can put up the request with a certain amount of money as the payment, and if someone comes along and is willing to sell me that kind of data, then we can engage. Otherwise, I'm able to redeem that payment. So here's a little bit how it works from sort of a systems approach, where we have this agreement as a smart contract that lives on Ethereum. We call it a griefing agreement, but really this is where the stake lives and where the rules are defined for the counterparty to exercise the punishments. So the idea is that both Alice and Bob are interacting with Ethereum through a client. And this client is doing a lot of different things on behalf of the users, right? It's storing all of their signature keys and their encryption keys. It has a wallet, so it stores a lot of their cryptocurrency. It has a data store, so it's able to access local data storage and store all of their data that they're trying to submit to the protocol. And then it has also a way of talking to Ethereum using a Web3 provider. Now, if Alice or Bob want to start an agreement, either of them can create this agreement using sort of a predefined set of initialization parameters. these spawn the contract and inform the counterparty that there's a contract available for them to participate in. Once this agreement is created, then the party that is selling the information is able to stake some amount of tokens, and that essentially gives the right for the counterparty to come in and either punish or reward them. When a punishment or reward is issued, it changes the state of the smart contract. If it's a punishment, then it actually burns the tokens and destroys them from existence. Then as the agreement comes to a term, let's say the duration passes, then Alice is able to retrieve the remainder of her stake and go on to engage in other agreements. So a lot of these components become quite manual. Let's say you're hosting this in a web app. You have to monitor for all these different transactions, see as they occur on chain, and then allow new actions to be taken on behalf of the counterparties. But the way that we envision it going is essentially there being a nice SDK that wraps all of these different components for for application builders to integrate into their apps, regardless of the platform that they're working on. So if someone's trying to work through a CLI, or if someone's trying to work through a mobile application, they should all be exposed to the same capabilities wrapped into this Erasure client. And it's worthwhile to note that this Erasure client right now is very bare bones. So this is where there's a big opportunity for hackathon participants to take some of these components, bundle them together, and provide sort of a simple interface that application developers can use across platforms. All right, on to the second primitive of track record. And this is the one that's most prominent in Erasure Quant. So once again, Alice interacts with the protocol through the Erasure client. She's able to back up all of her encrypted data by storing it in some kind of decentralized storage. For Erasure Quant, we use IPFS, but in theory, if you install the right plugins, or if the Erasure client is able to support it, then you could have a redundancy across many different storage networks. The reason why it's really interesting to back up all the data on decentralized storage is that you actually get cross-platform recovery by default. So let's say Alice is using her PC to submit this data. Well, the Erasure client stores the encryption key, right? Uploads all the encrypted data to decentralized storage. And if she then wants to access it from her mobile phone, all she needs to do is transfer these keys to her mobile client. And all of a sudden, she's able to pull the same data from decentralized storage and have access to it on any other device. So this ability for the Erasure client to transfer keys from one device to another would be something that would be really interesting for someone to build. All right, great. Now the data is backed up in decentralized storage. What if Alice wants to start building this track record, right, on top of Ethereum? Well, on Erasure, there's something called a feed contract. And that's simply a contract that stores a series or an array of proof hashes. Now, the proof hash contains everything that's needed for Alice to prove that she owned a specific piece of data at a specific point in time. The format of it is built to match what a lot of decentralized storage systems use, which is a multi-hash, which sort of guarantees the ability for the hash to remain valid throughout time. And it's a hash of the user address, so Alice's Ethereum address, along with the salt to prevent someone from observing what the data is, and her data itself. So this hash is stored in this feed, and as she continues to submit these hashes, she starts building this track record, right? And anyone can observe this, everyone can see, I don't necessarily know what the data is because she hasn't revealed it, but I can see that she's submitting something consistently. Now, at some point, Alice may decide to reveal this data. And to reveal it, all she has to do is upload the data to this decentralized storage, and anyone can then compare by reproducing the proof hash. So by hashing that data with her address and the same salt that she used, they can compare that this data uploaded to decentralized storage matches the data in her feed contract. Now, there's a lot of complexity here that's handled by the Erasure client, right? Doing all the uploading, doing all the encryption, scheduling when the reveal can happen. And this is something that we've custom built so far for the Erasure Quant and Erasure Bay applications, but is another opportunity for someone to wrap up together and provide a clean developer experience around. All right, finally we get to payments, and this is used through an escrow on top of Bay. So in this case, we have, again, two parties, Alice, which is the seller, and Bob, who's the buyer. They are each hosting their own client, and then they engage in this sort of dance of exchanging data. So the buyer, Bob, can upload his public keys, so his public encryption keys, to Ethereum inside of a user registry. And he also spawns an escrow contract and submits a certain amount of tokens that he's willing to pay for the data inside the contract. So with that deposit then, Alice is able to see that he has made a credible commitment to buying this data. She can retrieve his public key and essentially use it to encrypt the data when she submits it to him. At the same time, Alice, instead of re-encrypting the entire data using Bob's keys, she's actually just going to do sort of a symmetric encryption of her data, upload the data to decentralized storage, and only re-encrypt the symmetric key with the buyer's keys. So this exchange essentially allows to minimize the amount of data that needs to go on chain to get passed over through the escrow contract, and instead uses decentralized storage to store the bulk of the encrypted data. So once Alice submits this encrypted symmetric key back to the escrow contract is able to atomically do the exchange of tokens for that encrypted key. And at that point, the buyer can go and retrieve the data from decentralized storage. So again, this is a lot of complexity that's handled by the Erasure client that we've sort of custom built for our applications, but would be wonderful if someone's able to build it together such that these interactions are completely seamless for the end user. All right, so those are sort of the first three primitives that we've used for building our three applications, Numerai, Quant, and Bay. But there's an opportunity to build other applications with this. And our honest thesis is that these applications will only be built if it's simple enough for Web 2 developers that have no experience building on top of blockchains to plug into. And this is, I think, where we get the opportunity to talk a little bit more about what would it take for those applications to exist. Before we get to that, though, I think it's worth taking a short dive into the architecture of the protocol. Sorry?
We can see if anyone has questions.
Oh, that's a good idea. If anyone has a question, do post it in the chat and we'll keep an eye on it. Okay. So the way that we built the smart contracts is to, oh, here we go. We have a question from James. What incentive do I have to grief or warn others not to use a particular data source that conveys a benefit to others at my expense? So that depends. I mean, depending on the platform that you're using, you're either going to be trying to punish to provide a signal for other members of that marketplace to say, hey, don't use this provider. Or maybe you're just going to punish out of spite. So if someone sends you data that is completely wrong, well, you're able to punish them for having done that. And sort of your natural incentive is to prevent them from, wanting to interact with you in the future. So there's sort of a broad array of different setups here where you can tweak the different parameters for these agreements such that it models a specific type of relationship, right? You can have relationships in which the stake is massive because you really don't trust the party that you're engaging with, where the ratio is really low, so it becomes almost costless to do some punishments. Or you can have the opposite, where the person that's actually staking has this really strong track record, and so their stake is not that high. What they actually don't trust is a counterparty that's buying from them, and so their stake is going to be small and the cost to punish it will be much higher. So I think it very much depends on what the what the actual setup of the marketplace is like.
Yeah, and one thing I just wanted to add there. So another example of a time where griefing is actually rational is in a continued relationship. So if you are engaging with someone and you plan to continue to purchase some sort of information from them that's in like a standardized format, such as in a data science competition, griefing can actually be a rational way to encourage good behavior or punish bad behavior that overall could make you more money than it would cost. And then the other thing I just wanted to make clear is that you can create an agreement where it is completely costless to grief. So the ratio could be basically 0 or infinite.
Does the protocol support different on-chain pricing mechanisms for assets? So I'm not sure exactly what you mean by assets here, but let's say that you mean just pricing the data. And how does price discovery happen? For the moment, it's quite simple. So we don't have any auction mechanisms, but it's something that could definitely be built as sort of these modules that plug into the architecture. I think it would be interesting for me to talk a little bit more about what the architecture is and where I see those diverse modules like price discovery modules fitting into the rest of the protocol. So when we set off to build this, we sort of knew from the start that we needed it to be completely decentralized. We couldn't make any compromise on the way that it's built out. We couldn't have any shut-off switch. We couldn't have any censorship. So that was a first requirement. The second one is that it needs to be quite simple for everyone to monitor and know where the single source of truth is. Because we're doing these track records, we must prevent people from being able to fork their track record into whatever preferred outcome that they have. And the third one is that it had to be future-proof. So we had to build in enough flexibility for us to be tolerant to future innovations on Ethereum specifically, because so many things are still in flux and changing. And finally, it had to be modular. And this is sort of a security guarantee where by keeping every component independent of each other, we're able to prevent the risk of a single component taking down the rest of the system. I'll skip this because this is a bit of technical deep dive into different approaches of architectures. And I'll go right into talking about the way that we've done things. So we've called it clone factories, which is essentially the idea that there's this clone registry that stores every single component in the protocol. It provides a single source of truth. And the way that you add components to this is essentially through a clone factory. Now, these factories' only job is to produce new smart contracts following a given template. So on the left-hand side here, we have the griefing template, right? And the clone factory uses that template to produce a series of clones. So if I am to engage, for example, on Erasure Quant, what I'm going to do, the first step is to call the clone factory, create a new instance of a griefing template that is my own, and interact solely with that clone from there on. So each of the clones are completely modular from each other, such that a given vulnerability on one won't affect the users that are using other instances. Now, each of these clones are registered back into the registry, such that by monitoring this registry, you get this single source of truth, this single array with all the different components in the system. So the feed template and the escrow template are all doing the same thing. They're all registering back into their appropriate registry. Now, this is future-proof because it's quite easy to create a new template for the system. So for example, if we wanted to create some auction mechanism, let's say it's a second price auction using some kind of blind bids, then we implement that through a new template, attach it to a factory, and then add the factory to the registry. And then at that point, any user would be able to start calling this factory and registering the new instances into the registry. So those are the three primitives of Erasure. if there's any question about this architecture, now is a good time to ask it. Okay, let's talk a little bit about, we have a question from James. How do dApps with US users comply with gambling laws? I'm not sure. I think that that's a question for lawyers, not necessarily for application developers, though it is a valid one. I'd say check with your local law enforcement for that kind of information. Okay, so we talk about Erasure. A lot of the idea behind the hackathon has been that we've had a lot of interest from various different groups and teams are interested in building applications using Erasure, but very few of those teams had any experience building on top of blockchains. And so they've asked us essentially to build a lot of the blockchain components, a lot of the backend components, and provide a simple interface for them to use, such as an API that they would be more used to building. That's not really something that we want to build on our own. And so we thought having a hackathon would be a great way to bootstrap that ecosystem of tools that will allow all these developers to start building these great applications. Now, the categories that we've chosen for judging these submissions are speed up in app development, the first one. How much quicker is it to launch an application on Erasure using the tooling that you've built? How well does it integrate with other tools in the blockchain world? Is it all of a sudden that, by creating this plugin, I'm able to access these mobile wallets that exist on most people's phones already? Then that sort of is a huge driving force towards adoption and extremely valuable. And finally, new frontiers. So providing new primitives that allow for building new kinds of applications. I think this is something where a price discovery mechanism would be really interesting. Building in some kind of auction system that allows for new kinds of assets to be traded. Prizes, judges, I'll let you guys read that for yourself. Let's jump right into the project ideas. So one of the main ones is building this Erasure client that I've discussed quite a bit about. Building something that's cross-platform compatible, that's storing all these different encryption keys, maybe using some existing secret store system from Parity or Geth. Something that's able to monitor the chain and take some actions against the protocol based off of monitoring certain events. Maybe something that's configurable, maybe it's something that's just default to a specific interaction. Having some integration with other identity systems would be really interesting. Some of the ones that we're excited about is 3box and Keybase, and seeing as you could port your identity from those systems into the Erasure protocol could be something interesting. Maybe some integration with third-party wallets. So if you're able to provide a lot of the monitoring, for example, of your feed or of your agreements with push notifications into another wallet system, that could be great to see. This peer-to-peer file sharing. So we've sort of built all of our applications using IPFS, and we've open sourced a library that helps people do the same, but there's other sort of decentralized data storage systems out there. And so providing an easy way to connect to these various different systems would be really great for the Erasure client. Then we have some other things like a fiat to Ethereum or fiat to token on-ramps. So there's a few teams that have been building these easier to use on-ramps. And if there's a way to plug this into just a drop-in SDK for the Erasure client, that'd be great. Then the user smart contract wallets. So this is not something that we've rolled out by default for all the users yet. We've sort of let it as an implementation detail for the applications. But if an application wants to provide gas abstraction or key recovery, or even wants to do some kind of custody on behalf of their users, then if there's a way for them to easily spin up these smart contract wallets for all of their users, it would allow them to do that quite easily. this also has the added benefit that you can simplify a lot of the interactions with the protocol, where you're able to chain transactions on chain directly, as opposed to have to do it by monitoring it through a client. So the other ones is Erasure packages. So this is essentially the components that would go into an SDK. So all the encryption, all of the interactions with the blockchain, all the interactions with decentralized storage, maybe some development environments using tools like Builder would allow people to iterate more quickly on their tooling. And then an Erasure API is another idea that has been floating around. So essentially this would host a lot of the complications of doing your own key custody, maybe adding another layer of abstraction on top of the need for holding either Ethereum for paying for gas or holding tokens, and just provide sort of an authentication system that allows for people to pay for their interactions with the chain using USD. And then all of the Ethereum is sort of bought by the API provider and relayed on-chain through their own system. So there's a few other listed on here. I'd encourage you guys also to take a look at the resources. Now the documentation is quite bare bones. So if you have any questions, just feel free to jump into the Rocket chat that we've set up for the hackathon and ask them there. We'll keep an eye on it and be very quick to answer those questions. Otherwise, all of the code for the packages that have been released so far are included in the Erasure GitHub repository. So we're using a mono repo where we have all the contracts that are on chain right now in this contracts folder. You can look at the releases to see what the current contract addresses are and where they exist on mainnet and on Rinkeby testnet. We also have a subgraph with the graph protocol that is hosting all of the, or at least providing a GraphQL endpoint to query all the data from the smart contracts. So that's something you can play around with as well. There's a dashboard builder put together by the Dune team that sort of allows for easily querying some of the data on chain and building various different graphs out of it. And then finally, there's a cryptography utility package that wraps together the cryptography and the IPFS interactions that we've been using for Erasure Quant and Erasure Bay. So that wraps up all the content that I had to share. If anyone has any questions, please ask now.
Thanks, Stefan and team. If you have any questions, feel free to unmute yourself to save the trouble of typing down your question. You can just talk to them.
Hi, I have a question.
Go ahead, Santiago.
Do you have already integrated with Enigma or NuCypher on your protocol, or this is something that you want to integrate?
Sorry, Santiago, I had my volume off. Could you ask that again?
Okay. I want to ask you if you have already integrated with if your protocol have already some kind of integration with Enigma or NuCypher, or this is something that you want to integrate in the future.
This is something that we've looked at quite a few times in the last year. We haven't had the specific need in our applications to integrate it because it didn't quite offer completely the additional experience that we wanted, but it's something that would make a lot of sense. And so it might be something that we'd either build ourselves in the future, or we'd encourage anyone else that's looking to build that kind of bridge into those protocols to do it.
Okay, great, thank you.
best place to discuss project ideas, find collaborators. I think definitely Rocket Chat is where we've been pointing everyone to. So if you post a message in there, you'll probably be able to get some response to it. We tend to have a lot of people hang out on Telegram as well. So if you want to post a message there saying, hey, listen, let's talk more about it in Rocket Chat, that would be a good idea. The problem with Telegram, as always, is that there's a lot of noise. So it's probably best to transition the conversation over to Rocket Chat.
I have a question. It's Brett here. The protocol seems to be, like you suggested, 3 separate primitives. Is there any integration between those 3 primitives? Like, do they interact with each other in any particular way? Have they been plugged together to make interesting products, or they're separated by the 3 different things that they do? I'll mute myself now.
James, you want to talk about that a little bit?
Yeah, sure. So, so we've been experimenting with integrating them for specific purposes. So, specifically with Erasure Bay, we're doing a specific type of briefing coupled with the escrow payments. So, and it also is coupled with posts. So yeah, exactly. Those are meant to be combined in various ways, especially for people with Solidity chops. We'd love to see new ideas on how to bring those things together. But also they totally can be integrated without actually having to talk to each other on Ethereum, meaning you can build an application that makes use of those 3 primitives and handles the integration off chain. So, that's an approach that we took more with Erasure Quant, where we're sticking things in metadata to make sure we're keeping track, but we're largely integrating those primitives off chain. And then with Erasure Bay, that's an example where we have a new sort of wrapper contract that brings these primitives together in a specific use case. So we're excited to see either approach.
Yeah, I think that's the great answer, where it depends on the use case. If there's a need for an on-chain interaction to happen in between these components, then that can be built using, for example, an escrow that spawns an agreement once the escrow is completed, right? That's what we're using for Bay. But if there isn't a need for an on-chain interaction between 2 things, for example, on Erasure Quant, we have a griefing template and a feed template for each of the users, and they're related to each other through metadata. So in the metadata, one points to the other and the other points to the feed, such that as an application, you know what the relationship is, but they don't necessarily to interact on chain.
Cool. Does anyone have any more questions for the Numerai team while they're here? Looks like everyone's just taking in all of the content that you've delivered right now. That's cool. We'll definitely send everyone a recording of the workshop. If you're registered for the workshop, you will receive an email as soon as the recording is live. And we hope that you have fun with your projects. Do join Rocket Chat. We will also we'll also send in a link to the Rocket Chat if you're not already in there. And we hope to see really cool projects from this hackathon.
Great. Thanks everyone for tuning in.